So we are going to continue discussion on limits of functions graphical approach. Okay, so let's recall what we had last time. So we were talking about limits of functions graphical approach. So we say that in pre-calculus, given x, which is equal to a, and a is in the domain of f, where f is our function, normally what we do in pre-calculus, we find the corresponding value of f of x, that is f of a. Na? In calculus, we're not interested in function values only. We are also interested in the values around f of around x, no? Values of functions around x equals a. So given values of f of x in the domain of f approaching a, but a not necessarily in the domain of f, we normally find the number that the corresponding values of f of x approach. So let us illustrate this graphically. So let's say I have this graph. Here, a is in the domain of f. We want to know what is happening to the function values of f as x gets closer and closer to a from its left and from its right. So meaning, I'm going to travel along this curve from the left of a. So travel. As I get very, very close to the point where corresponding to x equals a. So where do corresponding values of f of x tend to go? Okay, so the values tend to go to, in this case, L. Na? So what about if I travel along the curve coming from the right of A, but close to A? So travel. So as I get closer and closer to this point is in the curve, no? Because A is in the domain of F. So what is happening? What is happening to the function values, to the corresponding function values? So the corresponding values of f of x approach where? Approach to this value L also. So that's actually what we want, no? We want to find out if there is a number that the corresponding values of f of x approached. Okay? So, and in this case, there is. So we say that there is a limit or limiting value for f of x. Okay, guys? So what about if a is not in the domain of f? So it means the corresponding point when x equals a is a whole. The function is not defined at this point. Is that clear, guys? But what I want is the behavior of f as I travel along the curve from the left of a going to this whole. So again, I'll be traveling or moving along this curve from the left of A. So as I get closer and closer to this hole, what is happening to the function values of f of x? So the function values approach what? Approach this value, no? So what about if coming from the right? As x gets closer and closer to A, so meaning as I travel along the curve from the right of A until I get very, very close to this hole. So what is happening to the function values of f of x? So the corresponding values of f of x approaching what? Approaching to this number. So meaning there is a limiting value approached by the function, no? So that is we are obtaining or attaining a limit. Okay? So in other words, it doesn't matter whether A approached by X is in the domain of F or not in the domain of F. It's still possible for the limiting value to be attained by what? By the function value as x approaches this a. Okay, guys? So see the difference of the limit of a function and function value. So it is possible even the function value does not exist, possible for the limit to exist. Is that clear, guys? So our goal is to determine how f behaves near or close to x equals a. So that's our goal. Okay? So important notations. So when you say x approaches a, or x is arbitrarily close to a, but x not equal to a, we write this in symbols, no? So this is how we write it. Again, x approaches a, or x is arbitrarily close to a, but x not equal to a. This is how we write it symbolically. X with arrow going to a. What about this notation? The corresponding values of f of x approach L, or simply f of x approaches L. So how do we write that symbolically? So we write that f of x approaches L. Is that clear, guys? So that's how we write this verbal form symbolically. So what about this notation? What does this mean? Anyone?
It is approaching A from the left side po.
So x approaches a through values of x near or close to a from the left, or simply x approaches a from the left. Is that clear, guys? Okay, very good. So we have this notation. What about this? What about this?
X approaches A through the values of X near or close to A from the right side po.
Oh, very good. Or simply, x approaches a from the right. Okay, so again, this symbol means x approaches a through values of x near or close to a coming from the right. Or simply, x approaches a from the right. So this symbol means what? F of x approaches L, or this statement means, so this statement, f of x approaches L as x approaches A na. So again, what does this mean? F of x approaches L as x approaches A. In a compact form, we can write this as what? This f of x approaches L as x approaches A as what? As limit of f of x as x approaches A is equal to L. Okay? So this symbol or this statement written in symbolic form is the same as this symbolic form, limit of f of x as x approaches A is equal to L. Is that clear, guys? So, and this is read as what? The limit of f of x as x approaches A is L. Okay, guys? Similarly, if I have this notation, f of x approaches L as x approaches A from the left, so we can write this in a compact form, limit of f of x as x approaches A from the left is equal to L. Okay, guys? So, and then the second one, we have f of x approaches L as x approaches A from the right, symbolically in other form. So we have limit of f of x as x approaches A from the right. So that plus on top means from the right is equal to L. What about determining limits of functions graphically? What we had last time, no? So let's say we want to investigate the behavior of a function near x equals a, and to determine whether the limit at x equals a exists or does not exist. We are going to write in short form does not exist by DNE. So when I say DNE, it means does not exist. Or if you want small letters, DNE. Okay, guys? By considering the graph of a function. So let's have number one. Let's say I have this, no? So let's begin with um, from the right. So from the right of 4, as I as I get closer and closer to 4 from the right, so this is how I write it or how we write it. As x approaches 4 from the right, let's check where the function values tend to go, no? So again, I will be traveling from the right, going to 4, meaning I'm going to approach this point. So travel, travel, travel. Or where do you think the value tends to go? Or the function values tend to go?
2.
Guys, tend to go to 2, no? So meaning the limit of f of x as x approaches 4 from the right is equal to 2. Now what about from the left? As x approaches 4 from the left, so I will travel along the line, going to this point, travel, travel, travel. So as I travel along the line, going or approaching this point is on the line, no? Because 4 is in the domain of this line. Okay, so the function values tend to go to 2. So we say that 2 is the limit as x approaches 4 from the left. Okay, guys? Now, since the limit of f of x as x approaches 4 from the left and from the right are equal, we can write these behaviors of function near x equals a as what? As one notation, no? Or in one compact form. So collectively, we can write this as what? So again, since we get the same behavior from both the left and the right of x equals 4, so these behaviors can be collectively written as f of x approaches 2 as x approaches 4, or equivalently, limit of f of x as x approaches 4 is equal to 2. Okay, guys? So let us consider another graph. By the way, we say that the limit exists and is equal to 2, no? Note that here, f of 4 is equal to the limit of f of x as x approaches 4. They are both equal to 2, the function value and the limit. Let's see if that is always the case. So in this number 2 that we had, so as x approaches 4 from the left, the function value f of x based on the graph approaches what? The function values approach 2. Okay? So we say that the limit of f of x as x approaches 4 from the left is equal to 2. What about from the right? From the right, so approaching 4, so I will travel along this line. So approaching 4, okay, or meaning approaching to this hole. So the function values tend to go to 2. So we say that the limit of f of x as x approaches 4 from the right is equal to 2. But notice here, 4 is not anymore in the domain of f. Okay? So the function value is undefined at x equals 4. But look at the limit from the left and limit from the right. They both exist and are equal. So collectively, we can write that as what? Limit of f of x as x approaches 4 is equal to 2. Is that clear, guys? Guys?
Yes po, Professor.
Yes po, sir.
So we say that the limit exists even though f of 2 is undefined. Here, f of 2 this time is not equal to limit of f of x as x approaches 4. So what does it mean? Anyone? So what does it imply? If you're going to look at the example of number 1 and example of number 2. So possible for the limit to exist even what? Even though the function value is not
Is
defined, no?
undefined po.
Okay, at that number. Okay, guys?
Yes po.
Let's have this third one. So let's say we're given this function where this f of x is defined by two expressions, no? So, or two different functions, no? One is less than 4 or equal to 4, and then the other one greater than 4. Combining these two at different parts of the domain of f, so we come up with y equals m of f of x. And this is the graph. So as x approaches 4 from the left, so again, as x approaches 4 from the left, I'm going to travel along this curve coming from the left. So travel, travel, travel. Oh, where do the function values tend to go, guys? So as I travel along the curve from the left, going to this point, okay? And this point, the function is defined actually, no, at 4, and the value of f of 4 is equal to 2. But what is the limit there, guys? 2, no? So as
Opo.
x approaches 4 from the left, f of x approaches 2. So meaning the limit of f of x as x approaches 4 from the left is equal to 2. But let's see coming from the right. As x approaches 4 coming from the right, so coming from the right, as it gets closer and closer to 4, travel, 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 I'll be very, very close to this hole. So as I get closer and closer to this hole, so the function values tend to go to 1. So meaning its limiting value is 1 coming from the right, no? So the limit of f of x as x approaches 4 coming from the right exists and is equal to what? To 1. But you notice that coming from the left, coming from the right, they have different behaviors, no? But we want same behavior coming from the left and coming from the right. Since we did not attain same behavior from the left, from the right. So we say that we cannot express it collectively as one what? As one
As one limit.
notation, no? So we say that the limit does not exist. Okay, guys? So again, we cannot collectively express these behaviors, and hence we say that the limit does not exist. Is that clear, guys? Or DNE. So that is the limit of f of x, although it exists coming from the right, the limit of f of x coming from the left, coming from the right, it also exists, no? But not equal. Therefore, we say that the limit of f of x as x approaches 4 does not exist. Is that clear, guys? By the way, if you have limit of f of x as x approaches 4 does not exist, you don't put equal, ha? Guys, again, you don't put equal to limit of f of x as x approaches 4 equals does not exist. So it doesn't sound good. Is that clear, guys? Guys,
Yes po.
Yes
do
po,
not
sir.
put equal. Once you put equal, I will not be correcting it. I will be marking it wrong. So just write limit of f of x as x approaches 4 DNE, or does not exist if you want in long words, no? Using 3 words. You can use also smaller DNE, smaller letters if you want. So again, even though the limits from the left and right both exist, so we say that the limit does not exist in this case. So again, possible for the limit to exist both from the left and from the right, but the totality, the limit does not exist. Sorry. Okay, so let's have that fourth one. So we are now in this. So let us have another scenario. Let's say I have this function. I do not know what's happening. It's blinking in my computer. Nagbi-blink siya. Pero I think in your case, hindi naman nagbi-blink, no? Nagbi-blink
Hindi
yung
po.
screen ko eh. I do not know why. Okay. What about this? So let's see how the function behaves as x gets closer and closer to 4, coming from the left, coming from the right. Let's start coming from the left. So as x gets closer to 4, coming from the left, what is happening to the function values of f of x, guys? Guys, as x approaches 4 coming from the left, what's happening to the function values? Guys,
It's
It's
going
approaching
upwards.
infinity po.
so f of x, what? F of x approaches
Infinity.
infinity. Actually, what? Yan. And that is positive infinity or simply infinity, no? Positive infinity. So what does this mean? We interpret this f of x increases without bound. Increases positively without bound. Okay, guys? Positively without bound. Hindi ba nagbi-blink sa inyo? Nagbi-blink yung screen ko positively
Hindi po.
without bound. Do you experience that, guys? So again, what does this mean? F of x approaches positive infinity. F of x increases positively without end. Meaning it keeps on what? Growing. It doesn't attain a specific value. Actually, this limit does not exist also. Okay? But it is specific that it is growing without end. And we don't attain a limiting value also. Okay, that's why it is also a limit that does not exist. Is that clear, guys? Or equivalently, how do we write this, guys? Equivalently, guys, this behavior, limit
The limit of x
of f of x
as x approaches infinity or positive infinity.
is equal to
Oh,
what? Ay, sorry.
mm,
As x approaches
Ay, hindi, x
4
approaches 4 po.
from the left is equal
Is
to
equal
what?
to positive infinity po.
Here it's all right to write because that's limit, meaning the limit
Mm.
is not is getting bigger and bigger without end. This is interpreted also as a limit that does not exist, but is specific. What specific behavior? Infinity. Unlike before, the limit does not exist. For what reason here? Guys, both from the left and from the right, although they both exist but not equal. That's the reason why the limit does not exist. The limit here, the reason why from the left does not exist, because it's positive infinity. Is that clear, guys?
Yes po. Professor,
But
for
we write
anything that
positive
approaches
infinity. Do not
infinity.
write anymore DNE. Understood that it is DNE, but specifically positive infinity.
Okay po.
So as x approaches 4 from the right this time, nahilo ako, nagbi-blink yung screen ko. I think there's a problem with the screen. I don't know. First time to blink like that. As x approaches 4 coming from the right, where does my f of x tends to go? Tend to go, I mean. Where does f of x tend to go? Anyone?
Positive infinity.
So again, from the right, it tends to go upward without end. So positive infinity. So, and we know that the interpretation already, no? Okay, guys? So, equivalently, how do we write this? So, this is the verbal interpretation of that. So, we have limit as x approaches 4 from the right. It's my head is aching because the screen is keeps on blinking. Is equal to positive naman na my laptop. Yan, okay? So meaning, again, we interpret the limit still to be a limit that does not exist. Okay. Now, can we write using one compact notation these behaviors, guys? Can we write that using one compact notation? Guys,
Yes
what do
po.
you
Yes
think?
po.
So collectively, although the limit does not exist, but the limit does not exist in totality, but we can write that collectively as what? Collectively, we write limit
Limit of f of
of
x
f of x
as x approaches
as
4
x approaches 4
is equal to positive
is
infinity,
equal to
or dne.
infinity, no? So again, how do we interpret this? dn is
dne.
still dne, okay? But specifically positive infinity. What about this number 5? Let's have number 5. Ay, sorry. Erase this number 4. And then, okay, so let's have this. Let's say I have this graph. What about this? What can we say about the behavior of f of x? So as x approaches 4 coming from the left, what can we say about f of x? Guys,
Positive infinity po.
positive infinity. Or equivalently, how do we write this? Limit of f of x as x approaches 4 coming from the left is equal to
Positive. Positive infinity po.
positive infinity. Look at how the notation is written, ha? Yan. And then as x approaches 4 coming from the right, what is happening to the function values of f of x?
Negative infinity po.
So this time it keeps on going down, negative infinity, no? So how do we write this verbally? F of x increases negatively without bound or decreases without bound. Decreases without what? Without bound. Okay, guys? Or sometimes it is called increasing negatively without bound, meaning lumalaking number pero negative yung sign. So that is what it means by increasing negatively without bound. Is that clear? So how do we write this? In a compact form, limit as x approaches 4 coming from the right of f of x is
Is
equal
equal
to
to negative
negative
infinity.
infinity. So again, we interpret this as what? DNE, ha? So
Yes po.
that's how we interpret it. It's still DNE, but specifically negative infinity. And of course, negative infinity and positive infinity are not real numbers. They only denote the behavior that something or the function value gets bigger and bigger, either negatively or positively without bound. Guys, oh, how do we write that collectively? Collectively, we can simply write, we write what?
Limit of f of x
Limit of f of x
as x approaches 4 po
as x approaches 4
is
does
equal.
not
Does not exist po.
exist. DNE. Do not put equal, ha? If I see you writing this, limit of f of x as x approaches 4 equals does not exist, I'm not going to what? Correct that. Quotient. So that you can clearly see. Quotient. So limit of f of x as x approaches a, let's say you write it equals does not exist. So again, that is considered what? A mortal sin. Yan. Is that clear, guys? Guys,
Yes po.
okay. And I cross it. Anyone who will be writing this way, so it will not be marked wrong. It will not be marked correct, incorrect. Okay, so let's have another scenario, last scenario that I'm going to have. Actually, another possibility for the limit not to exist, where we have what we call oscillatory behavior. So normally that happens for trigonometric functions. As x approaches a specific number, the trigonometric function, for instance, is not attaining what? It's not attaining specific value. Okay? For instance, as x gets bigger and bigger without end, what is happening to the sine function? The sine function oscillates, or the sine function bounces back to what? To -1 to 1, -1, in between, and so on. Okay? So oscillating. So the value is oscillating or bouncing from -1 to 1. So let's have another graph. Let's say I have this graph. And then here, so it means the function value is defined but coming from the right, going here, and it has a point on the asymptote. But coming from the left, it keeps on going down, no? So how do we write that behavior? So we can go directly, no? Since you know already what it means. So for x that is less than 4, but of course close to 4, no? So how do we write the limit, guys? Limit of f of x as x
As x
approaches
approaches
4
4
from the left,
on the left is equal to negative infinity po.
negative infinity. I'm not going to write DNE anymore, huh? It means, of course, still the limit does not exist. What about coming from the right? What's the behavior coming from the right? What's the
X
limit,
approaches
guys?
positive infinity po.
Is it positive infinity or there is,
4.
let's say this is
3, 6.
3? Well, let me change the ano, to be
Oh wait,
specific.
3,
Let
6?
me change the,
The numbering, sir, on the
I'm going to adjust
y-axis.
so that it will, this 1, 2, 3. This is 1. And let's say it's somewhere here. The blue and white. Yan, here. Here it goes. Oh, what is now the limit? Coming from the right,
3 po.
3.
3.
positive 3, right? Na?
Yes po.
So coming from the right, the limit exists. Coming from the left, the limit does not exist. That it does not exist. Actually, it's negative infinity. So we can write collectively as what? If you're asked to write that collectively, we write what? How do we write this in one compact form?
The limit
Limit.
of f of x.
Of course, we cannot have a uniform, a uniform number for this, no? Kasi
Yes po.
from the left does not exist. As x approaches
Approaches
4,
4. F of x
simply
is
what?
equal is DNE lang po.
DNE.